Y'all, I need help. I'm having an existential crisis because I was looking at the stars last night and I was wondering, what am I made out of? But then, is that the same stuff as what stars are made out of? Is that the same stuff as what the black in between is made out of? What is going on here? Ah! It's okay, physics penguin. That's a great question. What is the universe made out of? Are we different than stars? Are we different than all the space in between? Let's find out, because we actually know some information to help us unravel these big mysteries of the universe. So, first of all, Physics Penguin, thank you for your great question. It's something that personally drew me to physics and to better understand why I am here, how I am here, and what I am made out of, and how I am different than a table or a star. So, let's talk about it because it is so cool. All right. So, first of all, we humans are made out of particles. So, protons, electrons, and neutrons are the three main building blocks of life. Those form atoms. And in the center of the atom is that nucleus, and then around that is an electron cloud. So, three main building blocks for our bodies. When you have atoms, you can combine atoms to form elements. That gives you the periodic table. That's where chemistry reigns supreme. Physics is in the world of particles or subatomic particles, meaning particles that are smaller than the nucleus. Ooh, so teeny tiny, very hard to look at. Chemistry is in the world of elements, so when you have multiple atoms that combine together, you get different elements. Elements form molecules, also in the realm of chemistry. And then with molecules, you get bigger building blocks that get you to biological systems, that get you to rocks. I'm simplifying. Those are areas that I know much less about than I know about physics, but that's how you get these building blocks that create things like plants and mushrooms and humans or animals. So, pretty wild, right? So, we, all living creatures, and pretty much every object or thing or rock that we interact with or experience or hear is made up of protons, neutrons, and electrons, which are made up of quarks, except for electrons. Electrons are made up of quarks. Protons, neutrons, electrons. That's really what you need to know. Three main building blocks of life on Earth and of Earth. Haha. Okay. But it turns out, here is the wild part. It turns out, if we draw a pie chart of the total mass energy of the universe, we are going to end up with three sections. Everything that we are familiar with is in this tiny section right here. Just, it's less than 5%. 4.6% of the total mass energy of the universe, protons, neutrons, and electrons, and other spicy particles. But generally, protons, neutrons, and electrons. So this is called baryonic matter. Baryonic matter, after Barry the penguin. No, I'm just kidding. I don't know where the term baryonic came from. But this is our experience, pretty much, of the universe in this little slice here. Okay, that's all fun and dandy, but like, what the heck is going on in the rest of this mass energy? Well, 24% is dark matter. Ooh, spooky. Not really. Physicists are just silly and have delightful and sometimes confusing names for things. But I really like the term dark matter, and it just comes from the fact that it's dark, it's invisible, because it does not interact with light. So we cannot see it with our eyes, with our telescopes, and with most of our imaging equipment, because the way that we take pictures generally requires light, whether that's x-rays or radio waves. All of that is light, and so it's really, really hard to take a picture of dark matter, hence why it is dark. Haha. But the matter part of this term gives us some hint. Oops, there's an R there. gives us some hint that, okay, maybe it's kind of related to baryonic matter, to the things that we are made out of. So when I was in physics, I worked in a dark matter lab, and it was really, really cool. I had a great time, and I learned a lot. The field has obviously changed and has made new discoveries since I worked in the lab, but the basic theory is the same. So the idea is that dark matter is made up of subatomic particles, or really, really small particles, just like protons, neutrons, and electrons. But these particles are different in that they don't interact with light. So the leading theory was that these dark matter particles may interact with the weak nuclear force, which basically just means they can bump into other particles that we can measure. So they interact with other forces, just not the electromagnetic force. However, these particles have been very, very, very elusive to detect. And the physicist that I worked for has spent 20 plus years trying to detect these in a lab, along with many other physicists, cosmologists around the world, trying to detect these elusive particles that we've known. We've known about dark matter since the 1930s. Vera Rubin confirmed it in the 1970s. We still haven't been able to detect them. Pretty wild. And not for a lack of trying, and definitely not for a lack of intelligence or skill. It's just that these particles are very, very different. So what physicists are trying to do now is to create them in particle accelerators, because we haven't been able to detect them directly. We have measured dark matter through indirect means, which is what Vera Rubin did by studying the rotational velocity of galaxies, basically how fast galaxies are spinning, and then being like, yo, the matter that I can see in my pictures does not match my measurements of the speed of the galaxies. They are spinning 400 times faster than they should be given the observed mass. So there must be some invisible mass. There must be some dark matter. Ooh, so fun. What a cool mystery. So, still a mystery, but it is actually really cool because through this process of trying to detect different particles, theoretical physicists will spin up a theory about, like, hey, what if it's this type of particle that has this mass or this energy? And then the experimentalists spend a lot of time going and checking these particles off. Well, you filter the theory, and then you're like, I want to go do that one, or this one seems doable. You get the low hanging fruit done first, and then you go into tackle harder things. So they've checked off many, many, many possible particle candidates. So they're narrowing the scope down, and getting to some of the particles that are harder to detect, hence why they're having to go use particle accelerators these days. Okay, so that's 24%. So we're at about a quarter, just a little over a quarter of the total mass energy of the universe. What is the remaining? Well, my dear friends, this is so cool. 71.4% of the total mass energy of the universe is, what do you think? It's another spooky fun term. It's called dark energy. Okay. And here I'm going to pause and be like, you're like, wait, but matter, energy. Matter, energy. One is different. Why are you conflating two different things? Units. Good job, my lovely scientist viewers. You are correct. These two sections are matter. They are probably particles. Well, definitely particles, probably particles. Not a particle. It's energy. But this is one of the things that Einstein was really famous for. He found that mass and energy are really the same thing. They're just different manifestations of the same thing. So, quick aside, that's what E equals mc squared means. It means that if a particle has mass, you can take that mass and convert it to energy. That's what we do with nuclear energy. We take the mass of an atom and we rip it apart, and out comes a lot of energy. Pretty cool. So it is actually okay. That's why I've been saying mass energy of the universe, because if you're asking what is the universe made out of, well, you gotta talk about all of the stuff in it. And some of that stuff we can't pick up with tweezers. We'd need very small tweezers to pick these things up. But You can't pick dark energy up with tweezers, but it still counts. It's still stuff that the universe is made out of. What is dark energy? That is a very big open question in physics. And if you're interested in physics, there are a lot of places to go poke around here. So if you want to, probe the mysteries of the universe, there's a lot of open questions in dark matter, even more in dark energy. Basically, what dark energy is the opposite of the gravitational effect. It has a repulsive gravitational effect, so it pushes things with mass apart. And we know that this exists because we have measured the expansion of the universe. Physicists are amazing, scientists in general are amazing. We've measured the expansion of the universe, and we found that not only is the expansion, well, number one, happening, the universe is expanding, things are getting farther and farther apart, but the speed that that's happening is accelerating, it's speeding up. And the amount of energy that would be required to do that is what we call dark energy. Another way to look at it is as the energy density of the vacuum, or sometimes people call it like the energy of space-time itself, kind of a little bit. So that's what the universe is made out of. Mostly things that we can't see, feel, hear, or touch. We are this tiny slice, this tiny, less than 5%. All of the stuff that we experience in our lifetimes is just less than 5% of the entire mass energy of the universe. Instead of making it kind of makes me feel small, but it also makes me feel so profoundly grateful to exist, because all of these building blocks that you and I are made out of, it's this little slice. We are a tiny slice of this big, vast universe, and yet we are here, right? I think that is simply miraculous. It's so cool that we get to exist in this space where we are kind of the outliers, right? And I love that. It makes me feel so appreciative to be alive. It makes me feel so appreciative that the Earth is here, that it happens to exist in this kind of perfect little orbit with the just right conditions. It's a stable planet over a long enough period of time to get complicated creatures like puppy dogs and butterflies and people. And I love that. And I love that science allows us to ask these big questions and seek answers and to be curious and to, keep moving forward even when it's hard, so that we can better understand our place in the universe, so that we can better understand what it means to be the universe experiencing itself. Ooh, all right. Okay, we're going to end on that. Thank you very much for hanging out with me and learning a little bit more about what the universe is made out of. I love this stuff, so please let me know if you have any questions, or if there are topics that we touched on that you want to learn more about, or other topics in science, tech, engineering, and math that you are curious about. Let's dig into it and learn more about this big, beautiful universe. Yay! All right, we'll see you next time, friends. Goodbye.